Hello there. In this video we're going to look at one of the most powerful differentiation techniques you will use in calculus, and it's called the chain rule. And without the chain rule, differentiating things would be extremely difficult. So in this video we're going to just be introduced to the idea of it. We're not going to actually produce the chain. Well, we are, sort of, but we're going to just kind of get an idea of the basic mechanics behind what's going on in the chain rule. And we're going to do that by this very ugly drawing that I've done. And I apologize, I am not an artist, as is evidenced by this first grade representation of some gears. These are gears. They are not suns or planets or anything like that. It's my attempt at drawing some gears with some axles. Okay, so you can see the sprockets engaging here, and then this sprocket right here is actually attached to this axle, which in turn is attached to this littler axle, which drives this axle right here. Okay, so I just want to make a couple of things clear before we get going. These gears right here are actually in front of these two. It's kind of a three-dimensional representation, and you could picture somebody being right here. Here's a little handle turning this thing, and as this thing turns, it turns the great big gear, which turns the purple gear, which turns the green gear, which drives the third axle. Okay, so hopefully that's clear to you. If not, if none of this makes sense to you, that's okay. You can still do the chain rule and get it, and hopefully the understanding might come a little later. But I do find if you can get this, it really does make sense. Okay, so here's the question that I have. If y, u, and x represents the number of revolutions per minute for axles 1, 2, and 3, what I'm interested in is the change in y with respect to x. I'm also interested in the change in u with respect to, I'm sorry, hold on, before I write that one, I meant to write the change in y with respect to the change in u, and the change in u with respect to the change in x. Okay, let's think about what these mean first. Okay, again, the mechanics of the chain rule you're going to find out are very, very easy, but the understanding behind it is maybe a little bit more complicated. Okay, so what does this mean to find the change in y with respect to the change in x? Well, what's y and x? Y and x happen to be rates of change of these axles. So if this axle turns 3 times, okay, if this axle turns 3 times, how does that affect this axle over here ultimately? How many times is this axle going to turn? Is it also going to turn 3 times? Is it going to turn 1 time, 9 times? We don't know. That's what we want to know. How does the change in this axle affect the change in this axle over here? Well, before we answer this question, before we answer what is the rate of change of y over x, let's maybe think about the rate of change of y over with respect to the rate of change of u. In other words, how does the rotation of this axle affect the rotation of axle number 2? Well, this is where our radii of the axle come into play. And over here I've color-coded the different radii for the different axles. So the purple sprockets up here have a radius of 1, and I know what you're saying, this axle looks bigger than this one, and it is, but pretend they're the same. Pretend I actually drew them to scale. The big one has a radius of 3, and the green one has a radius of 2. So I want you to think about, if this has a radius of 1, and this turned just 1 revolution, okay, you came over here on this handle and you turned it only 1 time, okay, what would this great big sprocket do? Would it turn 1 time as well? Well, clearly it wouldn't. Its radius is 3 times bigger, therefore its circumference is 3 times bigger. So if this only rotates once, then this big sprocket's only going to rotate 1/3. Okay, so this guy would actually have to rotate 3 times in order to turn the great big sprocket once. Well, there's your dy du. In other words, the rate of change of y, or I should say the change in y, that first axle would have to turn 3 times in order to turn axle number 2 1 time. Okay, it's a 3-to-1 ratio. Again, the change in the y over the change in the u is a 3-to-1 ratio. Okay, well, how about the second axle with respect to the third axle? Well, I want you to understand that this sprocket with the gears on it is attached to the bigger sprocket through the teeth, okay? But this sprocket is attached to the bigger sprocket by this axle. So if this great big sprocket turns one time, the axle is going to turn once, which is going to in turn turn this guy one time. So these guys are one and the same. If this turns 3 times, the purple sprocket turns 3 times. If this turns 10 times, this turns 10 times. Okay, so now my question is, what is the change in u? What is the change in u with respect to the change in x? Okay, in other words, when this sprocket turns, how does that affect the turning of this sprocket? Well, let's think about it. This sprocket right here has a radius of 1. This sprocket has a radius of 2. So if this sprocket turned only one time, it would turn this sprocket a half a time. So this guy would actually have to turn twice in order to spin this sprocket once, which in turn would spin the axle once. So what did we just say? We said that the change in u, the change in the second axle, would have to be 2 revolutions. And that in turn is going to drive that third axle 1 revolution. Okay, well, so now you can kind of get a picture of this. If the first axle turns 3 times, it turns the second axle once. But we know that the second axle has to turn twice in order to turn the third axle once. So how many times would the first axle have to turn in order to turn the last axle once? Okay, well, think about it. This guy would have to spin 3 times to turn him once, and we know he would have to spin twice to turn him once, so it makes sense that we would have to multiply. We would have to multiply these 2 rates together. In order to give us the change in y over the change in x. Okay, so this is 3, this is 2, therefore my overall change will be 6. So let's just look at the notation here. Okay, we just said that the change in y with respect to the change in x is 6, and we did that by going through these 2 other rates of change. Okay, now you could think of it this way. You can actually kind of think of these du's, sort of kind of canceling out, if you will. We don't really do that, but look what's left over. We have dy dx. So that's kind of, I suppose, intuitively why these 2 things are the same. But hopefully you saw why we had to multiply these 2 rates together in order to get 6 revolutions. Again, I'll just go through it one more time real quick. Think of it. If this spun 6 times, then this guy spun how many times? Well, if this guy spun 6, this guy is going to spin, well, what would he spin? If he spun, he would spin twice, wouldn't he? Okay, if this guy spun 6 times, he would spin twice. And that goes back to the idea that if he spun 3 times, it would spin this guy once. So if he spins 6, it makes sense that he spins twice. Well, if this guy spins twice, that spins this guy 1 time. Okay, so what we have here is this idea that the overall rate of change, the change in this axle with respect to the change in this axle, equals the change in the first axle with respect to the second axle multiplied by the change in the second axle over the rate of change of the third axle. We multiply them together, and that is the overall rate of change. Okay, in part 2 of this explanation, we will map out what the chain rule is, and we will do some examples. Hopefully that made sense. If not, I apologize to you for wasting your time, but if it did, congratulations, you now understand the chain rule and the mechanics behind it. Okay, so we'll see you in the next video where we will do some examples.